So good afternoon, everyone. As people still coming in, I have a quick technical announcement for the excursions tomorrow. So we're going to be 700 people on field trips, and we want to make sure everything starts smooth. So please check the departure times. There's a sheet on the information desk where you find all the departure times of all the field trips. And you find also the updated times on the website. And so most excursions depart from the entrance of the Congress Center right outside, but there are a few excursions by train. And if you're on an excursion by train, be very careful because the two major train stations in Davos. And some excursions start at Davos Platz train station, like the F5, and others start at Davos Dorf. So watch out which one it is. The other thing, it's clearing up. I think we're going to be really having good luck. It should be fairly sunny, but it will still be cold. So get warm clothes and sturdy shoes to be ready. Then the other thing is, afterwards on Friday it will snow, which is really beautiful, but we got some questions that a lot of people are here with cars with summer tires. So we think it's going to be safe to go down, but we check it out also with the road service, and we inform you on Thursday morning. But don't leave right away on Thursday. I think it's still going to be just very light snow. They salt everything it should be. But we update you on Thursday morning. So with that, it's a great pleasure to introduce another amazing panel after this morning's panel on groundwater education, again with a very global representation. Debating this afternoon on reversing groundwater depletion trends, and the debate will be led by Alice Aureli from IIH, and she will then introduce the panelists along the way. Please, Alice, thanks for being here.
Okay, we can go out. Thank you. Okay, we can start. So first of all, thank you for coming. Welcome to this plenary session. As has been just said, the plenary session will look at the current studies undertaken to evaluate groundwater depletion, and will consider what are the challenges and what are the available tools to allow us reversing groundwater depletion trends. Definitely, we are facing quite a schizophrenia. If we look at the last UN reports, these tell us that the world is not on track to achieve water-related sustainable development goals. FAO estimates that irrigated land in developing countries will increase by 34% by 2030, and that water use for irrigation will increase 14% by 2030. What to do, given the uncertainties of climate change, and what are the causes of failure in groundwater use, management, and policies? What hydrogeology can do, what the Association of Hydrogeologists, the IAH Association, can do. Is groundwater in danger? Well, we have only 60 minutes, so we have to be very efficient in presenting the messages we want to get across. We will then listen to two presentations by Hans-Georg Seibold and Donald John McAllister, and then we will have a panel discussion with some, I hope, provocative question and interesting answers. And then we will try to wrap up some conclusions. And that will be definitely also an interactive action with the audience. We are in streaming, so we hope that the audience around the world can also have the possibility to access this room with us. So I will not take more time because we don't have a lot of time. I will immediately give the floor to our two speakers. The first one is Hans-Georg Seibold from the ATH Zurich, so from the Federal Institute of Technology, the staff of the Physical Environmental System. And he will tell us about the acceleration decline of groundwater levels in the 21st century with few signs of recovery. The floor is yours, please.
Yeah, so welcome back after lunch, and thank you very much for the organizers to have this panel discussion here. As Alice already said, groundwater is a vital resource which we have to monitor in a certain way, and there are two principal ways today how this has been done. One is based on the remote sensing data of the GRACE satellite mission, which measures changes in the gravitational field of the Earth, and with some remote sensing black magic, one can back up water table storage anomalies at a very coarse resolution of 300 to 400 kilometers per pixel. Just see the map of Switzerland with the GRACE pixels in behind. On the other hand, since almost 100 years, we drill wells and we can measure the water level or the piezometric head in these boreholes. These measurements give local information about the groundwater table. However, these measurements are costful because you have to drill the well, and they are, even with modern data loggers and piezometric sensors, rather labor intensive. Consequently, they are mainly performed in regions where we particularly care about groundwater. In order to bridge this gap between this global picture and the local measurements, Scott Yasheko mounted a team of some people to collect groundwater piezometric measurements from any database we could access across the globe. We ended up with 1.5 million groundwater time series, from which 170,000 could be finally used to make a comparison of the groundwater trends of the last 20 years of the 20th century with the first 20 years of the 21st century. Here, a picture of the tiles and trends in a few aquifers. You see, even within a single aquifer, the trend of the groundwater can be rather heterogeneous. A second thing which you see here is that different aquifers are sampled quite differently. While, for example, in Southern California, Central Valley Aquifer, you have a dense network of monitoring wells. In this aquifer in Thailand, you only have a few wells that are sampling this aquifer. So in order to overcome this sampling bias, or to mitigate this sampling bias, Scott took the effort to digitize groundwater aquifer from maps in publications. Over 1,000 publications he took, and we spatially averaged the groundwater trend within these aquifers. See the map on the right-hand side, and on the left-hand side, how an aquifer can be averaged. So we have now averaged trends in the 20th and the 21st century, which we can compare. And we see clearly we have many more declining trends in the 21st century than what we have recovering trends. When we look at how these different trends split up, we see roughly 16% of the wells where the decline slightly decelerated. However, in a vast majority of the wells, the groundwater trend rapidly accelerated. In some places, even here by a factor of 4 or 5 what it was before. In some 20%, we even saw a reversal of a trend that former recovering time series actually got to decline. So to wrap up, I suppose globally we would all agree that it is not surprising that groundwater trends are going down. But what is stunning is the pace at which the groundwater decline accelerated in many places, particularly in cultivated drylands over the last 20 years. Depletion trends we see in a few places can be reversed after human intervention or reversed due to climate change, the redistributions of precipitation. And with this, I would like to give immediately to the next speaker, who we'll continue from here. Thank you very much.
Thank you so much. Yeah, definitely. The next speaker will be Donald John McAllister. He's a senior hydrogeologist of the British Geological Survey. And I mean, the title of your presentation is quite, intriguing. Apparently, you gave it to me, A Tale of Two Groundwaters, Charting the Opposing Arcs of Resource Development in an Era of Rapid Change. I think it's quite challenging. Please, the floor is yours. Not more than 5 minutes.
Thank you very much for the opportunity. So yes, I'm hopefully going to tell a tale of two groundwaters this morning. And I'm drawing on the story that Charles Dickson, The Tale of Two Cities by a famous, very famous author. And the words that he started that book with, The Tale of Two Cities, where it was the best of times and it was the worst of times. And those words, I think, can apply to our debate around groundwater development today. So if we start with two cases here, so we have obviously the South Asian continent on the left-hand side, and this is a case where maybe things are terrible. We're in a very difficult situation. It's the worst of times. And if you look at this figure, so what you can see is the use of renewable groundwater within India. And you can see that particularly in northwest India and Pakistan, we're using as much as 500% of renewable groundwater resources, which leads to serious depletion, which is well known within this region. But actually, even within northwest India, there are nuances there. So in some areas, we see rising groundwater levels leading to waterlogging, for example. And then if we look across the rest of the Indo-Gangetic Basin, actually, we're using a lot less of that renewable groundwater resource. So there's some scope, potentially, for further development, even within India. On the other hand, if we look at the African continent, for example, we're standing potentially on the cusp of a solar energy revolution, which will open up the possibility of large pumping using solar energy. Potentially, we're at the best of times. And the renewable groundwater use in Africa is a lot less. So traditionally, groundwater may have been used for rural water supply. It's starting to be used more for groundwater, but actually we're only using, in sub-Saharan Africa, maybe between 1% and 10% of renewable groundwater resources. And obviously, even within Africa, there is nuances there. Look at the North African region, for example, and we know that we're drawing down fossil groundwater resources. I just want to spend a wee bit of time thinking about the long-term perspective as well. So we know that we have this issue of groundwater depletion in northwest India and Pakistan, and you can see that from about the 1990s to the present day, this is what these 4 hydrographs from that region show. But actually, if we look much further back to the start of the 20th century, we can see significant levels of groundwater accumulation in this area. So that's something that we wanted to look at in a bit more detail. So on the left-hand side of this slide, we've got the results from an analysis that we did of several thousand hydrographs in this region. And then on the right, it's just a block diagram of the implications of those results. And I'll just talk you through the results on the left. So we have from 1900 to about 1960, 1970, 350 kilometers cubed of groundwater accumulation within that region. And that compares to about 75 kilometers cubed of depletion from about 2000 onwards. And we looked at various different factors that were controlling this, including climatic factors. But what we actually found was that it was human intervention from the start of the 20th century in the form of canal development for surface water irrigation that led to these increases. So in that period, about 125,000 kilometers squared of canal command area was added. Those canals are leaky, and they raised groundwater levels, which is what you can see in the diagram, the diagram on the right. And then from about 1960, 1997 onwards, period of the Green Revolution, suddenly there was an explosion in the number of tube wells that were drilled that led to the depletion that we see today. But what's important about this is that it was human intervention early in the 20th century that actually created the conditions for large-scale development of groundwater later in the century. So it's really important to understand the long-term perspective, to understand how we got to where we are today in these environments, and potentially to learn lessons for policy going forward. I want to say something briefly about data as well, and this is a figure from the paper that Hans-Jörg and colleagues authored, and they've done an excellent job of compiling data from around the world. But actually, what this shows to me as well, very starkly, again, we have this tale of two groundwaters. If you look at South Asia, we have quite a lot of data. If you look at the African continent, we don't have much data at all. And we really need this data to understand, for example, in Africa, to understand basic hydrogeological properties at the start of this potential solar revolution. But we also need data to help management interventions, policy decisions, to help slow or reverse depletion. And this is just on the three diagrams on the right-hand side are three examples from the paper that Hans-Jörg and co published, where they managed to show examples of where management interventions have actually managed to slow or reverse depletion. So data is required for us to be able to achieve that. And then finally, I just wanted to challenge us to think about things maybe in a slightly different way, as possibly a tool to communicate with others. So to communicate with the engineers that are putting in these solar systems in sub-Saharan Africa, for example. So this is some work that we did with colleagues from Paris-Saclay, looking at the estimates of the maximum remaining installable power that we can put in across Africa without overexploiting the resource. And you can see the two assumptions that we've made on those two figures. And you can see there is potential, but the grey areas show areas where already there is potentially some overexploitation of groundwater in Africa. But it's a very nuanced picture across the continent. So that's just a challenge to finish off with. But thank you very much.
Thank you. Well, very nice that we end with Africa, and I remember very well at the World Water Forum in Senegal only a few years ago, when we discussed about groundwater being a real potential for development in the continent. But hydrogeologists immediately said, don't drill what you don't know. You have really to know where you drill and what you drill. I mean, groundwater is there, but we have to know exactly what we have under the soil. So definitely groundwater is there, but we need data, and we need hydrogeologists, and we need to have a clear capacity. Then I go to the panelists, to our panelists, the experts that are with us, Professor Seifou Kebede from the School of Engineering at the University of KwaZulu-Natal from South Africa, Dr. Karen Willow from the director, Will Holt, sorry, from Director of the Water Cycle Innovation. She's collaborating with several UN agencies. Dr. José Luis Martín Borders, Special Advisor at UNESCO. And Dr. Eric Arnos from the Secretariat of the UNEC Convention on the Protection and Use of Transboundary Watercourses at International Lakes, also called the Water Convention. And Eric focuses very much on water diplomacy and water governance. So, Africa, Seifou. Oh, they told me, don't move too much my head, because if not, this, yeah, sorry. So, Seifou, groundwater depletion in Africa, groundwater in particular in Southern Africa. Is the measurement of levels the only indicator? What about uncertainties due to climate change? And do you have any solution to suggest or some examples how to avoid or to improve the situation? 5 minutes.
Yeah, thank you so much. Yes, you know, listening to the two presentations, the first one on global depletion of groundwater, and then I was wondering if hydraulic head measurement is the best indicator of the challenges that we are facing in Africa and elsewhere. So it is one indicator, but it may not be the only indicator. So in that regard, Africa needs a Sub-Saharan Africa at least needs a more pragmatic approach, and not rosy, not over cautious and over sensitive, messages, but realistic message on the ground. This is because hydraulic height indicate water level decline and potentiometric surface decline, but it doesn't indicate immediate impact of that decline. The decline by itself could be tolerable. But it is not tolerable if the connected systems are impacted. The connected ecological and social systems are impacted. So decoupling the physical measurement from the socio-economic and environmental measurement is going to be unfair in my understanding. Maybe unfair is a very strong word. I'd find, if English was my first language, I'd find a different word. So what needs to be measured? Number one, from SDG perspective, what have we gained out of investment on groundwater, on SDGs, basic human needs? So along with the depletion, a rise in water, hydraulic height, what benefit has been obtained out of it? Number one. Number two, what are the other impacts? Yeah, it's about maintaining the dynamics of the water in the subsurface. So base flow, did base flow change? Did environmental flow change? Does the water quality change in response to human use of the groundwater? Or has there been subsidence because of overpumping? So measuring the water level alone will not, the hydraulic height alone, will not tell us the pressure that we have on the system. So it must be coupled with other systems. So that is on measurement, and then I'll come back maybe later. I think I've used my 5 minutes. So I'll come back later if I have time on the uncertainties associated with climate change. And then as a final thing that needs to be measured is like inequalities. As a result of overpumping and depletion, did that end up in inequalities among users, poor and wealthy, one region against the other, upstream, downstream? So depletion and measurement of water level must be accompanied by other indicators as well. So that is my take. Thanks so much.
Thank you, Saif. I mean, definitely Africa will be one of the continents where there will be a very increase in population in the next years. So, I mean, a request for water supply and water for economy will be very strong, and groundwater will play a crucial role. Well, how to solve this issue of depletion? I mean, we know that groundwater is not really in the international political agenda. Karen, what can be the causes? I mean, it's a lack of capacity, lack of policy, lack of governance. Scientists do not know how to bring science to the attention of policymakers, or is only a matter of intrinsic issue of our economic system. I mean, the schizophrenia between secure food production without depletion of groundwater. I mean, from the international point of view of the politics there, what we can say.
Yeah, thank you, Alici. Thanks also to all the other speakers so far to sort of shape the whole discussion. Maybe one thing to just start by saying that groundwater depletion is maybe not a precise concept. We're still struggling in the community to actually say what is depletion, how to measure it, and so on. And so I think that is, of course, a discussion and scientific challenge that we all have to address as part of the groundwater community. But I think maybe the good part about groundwater depletion as a very vague term is that at least it's becoming part of the global agenda in a sense. People are starting to acknowledge that we have a problem, groundwater depletion. And I think that's a good part, and then we'll have to work across on the further definitions. As you say, groundwater depletion is maybe not high on the agenda at the international level, and so we still have to work on that. And you ask, why is that the case? Well, I think there's, as you say, the capacity development side. I'm actually going to address each of them: the capacity development, the management aspects, and then the governance aspects. I think there was a session early this morning on capacity development, and that had a lot of traction. I think this is one of the fundamental issues of not addressing groundwater depletion is simply that we don't have the technical capacity, the know-how in the countries, and there's not enough priority in terms of investments in developing this capacity, in retaining staff, in funding and incentives for staff and so on. So I think that's a very fundamental aspect when you talk about sort of practical implementation of curtailing groundwater depletion. When we talk about management, we've talked a lot about integrated water resources management, conjunctive water management, circular economy and so on. I think groundwater needs to have a much stronger role in these agendas. We are addressing it now today through sessions on conjunctive water management. And I think the key point here is that groundwater has kind of been lagging behind surface water management. That's a kind of a legacy that we are dealing with now. So groundwater has not been subjected to water rights systems and so on. And this is where we are lacking in a sense. So groundwater is being used without having any rights. They're not being picked up. The users are not interested in having rights because if they can drill sort of without being seen, that's to their advantage. So the incentives of implementing rights and so on are maybe not in place, but this is where we need strong governance, we need strong policies and so on, and this integrated approach so that we make sure that we don't compromise one resource when we are running out of another source. On the governance side, I think we see kind of negligence of groundwater. We see myopic views of groundwater, but not a groundwater holistic approach. We see short planning horizons. Groundwater is a resource that responds in very long, on long horizons, and that is not taken into account by policymakers who have short-term assignments and so on. So these aspects are very critical for especially groundwater. Financing priorities, maybe they are not sort of conducive to supporting groundwater, sustainable groundwater management. One thing that I see, and I've talked about this with other people in this conference, is that a lot of present investments are going away from environment, generally speaking. We are trying to protect ourselves and using funds for kind of military protection and so on, which is a very, very detrimental kind of development, and I'm very concerned about that. And groundwater is probably one of the resources that are going to be sacrificed in that process. I think I will stop there and then I'll summarize afterwards. Thanks.
Thank you so much. Thank you so much, Karen. Yeah, I mean, there are lines for looking at these in a much organized matter, and certainly to have groundwater more visible in the international agenda. Well, we had Africa, we had Asia, India, and maybe we can go now to the Mediterranean area. Jose Luis, you are working in a very large program with more than 12 countries in all the Mediterranean area. And groundwater depletion in coastal zones is definitely a crucial issue, a real important topic for the people and the economy around. Possible tools for solution and examples. This UNESCO project is going on, is financed by the Global Environment Facility. So 12 countries, what you can tell us?
Thank you very much, Alice. Thank you very much to the other speakers and panelists. It's a pleasure to be here. If we want to talk about the Mediterranean region and the current situation of coastal aquifers depletion, we need to understand that the Mediterranean region, it's a particular setting in terms of climatic conditions and geological conditions, which make these coastal aquifers particularly vulnerable to overabstraction, but also they offer opportunities as means to adapt to climate change and climate variability. So let me just give you some background information about the status of the climate change and climate variability in the Mediterranean. The recent report from MEDEC shows that annual mean temperatures are rising in the Mediterranean basin. The summer rainfall will likely be reduced to 10 to 30% in some regions in the Mediterranean region. And the sea level, which has already risen by 6 centimeters in the past 20 years, will most likely be accelerated. This is the, I would say, climatic setting that we're talking about, but there's also the demographic challenge, where we see that coastal areas in the Mediterranean are being highly populated, and this, of course, together with the agricultural and irrigation challenge, cause increase in water demand. This is where the role of coastal aquifers come in. It was only in 2015 that there was a clear recognition by the transboundary diagnostic analysis that was conducted under a GEF project and led by UNESCO, that the role of coastal aquifers in the, I would say, a fragile relationship between the coastal zones and the marine system were recognized. And this, of course, laid the foundations for large investments in the Mediterranean, such as those funded by the Global Environment Facility, that look at coastal aquifers and the vulnerability vis-à-vis seawater intrusion, submarine groundwater discharge, and of course, groundwater-dependent ecosystems in coastal areas. These are the main, I would say, challenges that coastal aquifers face in the Mediterranean region, in addition to the fact that some of the so-called meteorological droughts have become, in many countries, structural droughts that have led to, I would say, urgent measures taken by countries to accommodate, to respond to their needs on water supply, especially for agriculture, but also for domestic use, leading even some countries to agree to buy portable desalination plants instead of investing in long-term planning or management plans for these aquifers. That could potentially be an alternative source of fresh water. Now, solutions. What are the solutions that these coastal aquifers could provide? There is a wide range. Some of them are being tested at local level, at pilot level, but of course need to be scaled up, provided that the necessary political and policy frameworks and legislation and standards are in place, and that the necessary funding resources are available. We can discuss about non-conventional water resources like salinization, use aquifers as a buffer through artificial recharge, the use of reuse of treated wastewater, especially for agriculture. That will, of course, have implications on legal frameworks and standards, as I said. But most importantly, how to propose conjunctive management of surface and groundwater solutions. And this is something that will require, and this was highlighted by Karen, special political frameworks that are very difficult to set up when groundwater resources are not known sufficiently. So again, more importance on research, characterization of coastal aquifers, and monitoring networks to provide data for decision making.
And you say short-term solutions. I mean, policymakers at a very high level, governmental level, I mean, often take very short-term solutions. And definitely to coordinate with the Ministry of Environment, the Ministry of Agriculture, the Ministry of Water Resources. Yes, I mean, it's not easy in the Mediterranean, of course, and in many other regions. This is, of course, one of the obstacles. I mean, how to coordinate this level of leadership on the top of natural resources. Everything's become even more complicated when groundwater flow below international borders, when we have transboundary aquifers. Now, Eric, the Water Convention, the UNEC Environmental Department, the Water Convention Secretariat, and UNESCO, you are the responsible for the monitoring of the SDG 6 indicator on transboundary waters and water cooperation. I mean, I'm right when I say that the transboundary aquifer depletion can really be an issue and that water cooperation could be a solution. And what is the role of the Water Convention helping in reversing the trend of depletion of aquifers that, of course, are national, but also transboundary aquifers?
Thanks, Alice. It is a very challenging topic, but I try to take a positive approach. So I'll try to reassure you a bit. I'm happy to say that transboundary groundwater cooperation and working to avoid transboundary aquifer depletion is firmly in the agenda of the Water Convention. We might not necessarily have to invent something new. We have some existing tools already, including the Water Convention, which is a global legal and institutional platform for water cooperation, not only surface water, but also groundwater. The main pillars of the convention, principles of prevention, the main pillars of the convention, such as reasonable and equitable use, the principle of prevention, all apply for transboundary groundwaters as well. And the convention requires parties to enter into agreements also on transboundary aquifers. So as I said, we already have this tool. And from my perspective, I think the best thing about the convention is that it's not just a paper. It's an institutional framework that can evolve based on the needs of the countries. And as a perfect example of this evolution is the upcoming program of work and the inclusion of conjunctive water management in this program. So countries have requested it, we have included it, and it is something that we will definitely work on going forward. In addition to providing this legal and institutional framework, we are working on developing tools to support transboundary groundwater cooperation. We have the model provisions on transboundary groundwaters developed together with partners such as UNESCO and IAH that provide non-binding guidance for countries that are interested in developing agreements over transboundary groundwaters. We also have the updated strategies for monitoring and assessment. I'm waving the publications around. I have a few actually with me, so if someone is interested, you can come and pick some up, which includes a dedicated annex on transboundary groundwaters. We're working on a compendium on good practices and lessons learned in data sharing, also over transboundary aquifers. And with the inclusion of conjunctive water management, we will work together with experts, probably many who are in the room and here in the panel, to develop some transboundary policy guidance on conjunctive water management. It's not only papers and documents, we also have some projects on the ground. We're working, for instance, in the Senegal-Mauritanian Aquifer Basin, where the model provisions are used as a basis for a legal agreement. We had a ministerial declaration in 2021 facilitated by us and partners, committing to establish a legal and institutional framework there. So yeah, I think it's quite clear that water cooperation can contribute to avoid transboundary aquifer depletion, but as has been mentioned here already, we've had strides in the right direction, but there's still a need to raise awareness. There's definitely a need for more science policy interaction. Together with UNESCO, we have conducted the third reporting exercise on SDG 652 on operational agreements on transboundary waters, and it clearly shows that there is work to be done. On groundwater specifically, we have 37 countries out of 153 that have 90% or more of their groundwaters covered by operational agreements. And with this rate, we are definitely not reaching the targets. On a positive note, again, the reporting has triggered follow-up actions. It has improved knowledge for countries on transboundary aquifers, and the reports are getting better and better. We have improved data and information also on transboundary aquifers. And on a UN, on a global level, at least, of course, we need to improve on bringing groundwater to the international agenda, but I'm happy to say we can talk about UN water conferences in a plural now. We will have more of them. We have the UN system-wide strategy that brings more cohesion on what the UN is doing on water. And the Water Convention provides an existing platform, a legal and institutional platform for also transboundary groundwater cooperation. So it's not all doom and gloom.
Thank you. Thank you. I mean, the Water Convention is open to all countries of the planet, and there are many countries that are now asking accession to the convention. And definitely, I mean, at the international level, we have a very close, important event coming, the next UN Intergovernmental Conference on Water in 2026. So definitely, there is something to be done by the International Association of Hydrogeologists to have a voice there on groundwater, because as Eric said, I mean, they are working with UNESC and UNESCO with 153 countries that share a river, a lake, or an aquifer, or sometimes all the three, and they have the data in their hands. The issue is that groundwater is not there. I mean, data on groundwater, capacity on groundwater, aquifers knowledge is not there. So these are facts and not, ideas like that. So thank you so much. Well, we have still some time before to go to the conclusion, and this will be very challenging for all the 6 panelists here, except by Professor Puri, that will give the conclusion. And I will give you 2 minutes, and I will put here the chronometer. And my questions are, there are other remaining issues that were not considered in this discussion, and or what you would like really to take on from this panel, or any recommendations. So 2 minutes each. Seifu.
Yeah, what I've learned sitting here is one size doesn't fit all. Yeah, so we have to see into the entire hydro, socio-ecological system when you design policies and send messages across. And then water level or hydraulic aid measurement is just a vital sign, an interesting sign, which is showing us damage that has been already made, or an imminent damage coming up, or a future damage in the pipeline. Thus, we have to combine this with other indices. I believe there are some other organizations who are working on, for instance, SDG, the benefits that has been obtained out of this investment. And to your earlier question on climate change, yes, uncertainties associated with that, there has been a number of work in Africa regards the groundwater systems, recharge, and the climate change, particularly by European and British Geological Survey, and showing that there is no hard and fact evidence that climate change is leading to degradation of the water available, the groundwater available in Africa because of the episodic nature of rainfalls. So under climate change, in some regions, not every region, there may be a tendency of increment in groundwater availability, but this should not be taken as a panacea and then to solve a problem. But it adds to the uncertainty. But what we don't know clearly is in humid, semi-humid regions in Africa, what will happen to the groundwater resources there under climate change. And then it must be looked into. And coming back, and my final point is about the nature of aquifers in Africa. One of these presentations yesterday showing nearly 40% of the aquifers are basement aquifers. Yeah? In basement aquifers, if you pump a borehole, the borehole would run dry quickly if you overpressure it. So prior to seeing a regional depletion, your borehole would run dry. So a water level or hydraulic aid there may not be indicating the real problems that is happening there. Maybe base flow is a good indicator. Environmental flow, drying of the health of nearby wetland is a good. So yeah, I think we need to work around what are the matrices, that we have to use. I liked one of the presentations yesterday on the socio-ecological systems, identify like 17 or 16 different systems globally, and then our monitoring will also, that can inform our monitoring and protection of our precious groundwater resource across the world in the future. Thank you so much.
Thank you. I mean, I would like to say that Africa is the only continent where there is a real serious coordination of all ministers of water.
Yeah, AMCOV. Yeah.
The AMCOV, the African Ministers for Water Coordination. And I don't know in other places. I mean, we, of course, in Europe, we have the European Community doing on that and the Environmental European Agency. But, I mean, they really meet every 6 months and taking real coordination. So definitely there are lessons to be learned in Africa on how managing water and groundwater resources. And, of course, the problem of lack of capacity is still there. You are a professor and you always tell this to me. It's really an issue. Karen, 2 minutes.
Yes, thank you. Thanks to Eric on the Water Corporation. I would like to pick up a little bit on that, saying that groundwater can really be leveraged in terms of attention by bringing it to the level of transboundary cooperation. So I think we should really push for that, because in that process, groundwater will have a higher priority among the member states. So that's very important. We've seen some examples actually today of 2 countries coming together to address their conjunctive management jointly and collect the same type of data and coordinate and collaborate around these issues, because they see they have the same problems across the border. This is Kosovo and Macedonia. So that was a very nice example today of how this can be taken forward. Climate change adaptation, I think groundwater has a very strong role to play there, and sometimes it's not really explicit. We do adaptation with groundwater spontaneously, opportunistic, but it's not planned as part of a good strategy for climate change adaptation, and that's when we run into problems. So I advocate for explicit climate change adaptation programs that include groundwater very closely. Thirdly, food systems. We haven't really discussed that, but most of groundwater in the world goes into food production. And so whatever happens to groundwater in food production is crucial to depletion, and we need much more focus on that. It's also telling us that groundwater depletion is oftentimes a local issue, because that's where the food is grown, but it becomes a global issue when water is transferred around the globe through virtual water in terms of food being exported and imported. So that's an issue that we also need to have much more attention to in terms of equilibrating sort of, where we have depletion and where we have the benefits of that depletion, because it becomes, at the end, this global fairness issue, if you like. Finally, a recommendation maybe, it's something that we discussed a little bit today, is whether we should take some of the messages from this conference to the World Economic Forum. Now we're in Davos, this is where they have the meetings. Maybe bringing the issue of groundwater to their attention in terms of future economic development and the importance that groundwater plays. Something to be discussed. Thank you.
Thank you. 2 minutes, perfect. José Luis, floor is yours.
My comment/recommendation would go in the direction of putting science and technology at the service of policymakers and management. And I think there is still a gap we need to fill. And the specific example I would like to propose is that we need more tools if we really want to promote and preach for conjunctive management of surface and groundwater. We need tools that can support management and decision-making regarding the exploitation or overexploitation of aquifers vis-à-vis the use of surface water. And for that, I think the scientific community should really look into the potential of coupling river basin models, surface water models with groundwater models understanding the complexity and the specificity of coastal aquifers, some of them, of aquifers in general, some of them with complex geology, and try to couple this and develop management support and decision support system for policymakers. I think this, of course, is linked to the collecting the right data to feed the models, but I think that there's a lot, we've seen in the Mediterranean some administrations, river basin organizations that are very much making decisions based on this, I would say, coupling of different models, including also in the matrix non-conventional resources. So adapting the management and the water supply to the demand, basically on a year basis, and again based on pluviometry and droughts, etc. So that would be a recommendation and a call for the scientific community.
Thank you. This brings me to this morning, the plenary this morning with John Cherry and the education, the survey that was shared during this conference. I mean, definitely, it's very recent that at university level we have going to have open for international law, for environment. I mean, hydrogeologists, geologists are really recently being able to touch to things that are not only, I mean, hydrogeological science. And this is crucially needed. I mean, in the profession, before in the university, we need definitely to have the possibility to understand what is going on in the economy around water, in the policy around water, in the international law around water, and not only look at the technicalities. If we want new policy makers and decision makers, I don't think there is any other possibility. Anyway, Eric, well, you just said conjunctive management and the great work you are doing in the Senegal-Mauritanian aquifer, like, I mean, the Senegal River Basin and the aquifer. So what is your taking home in 2 minutes?
I have take-home messages and I have an invitation. I'll start with the take-home messages. So to prevent conflicts arising from transboundary aquifer depletion, first of all, we need the intergovernmental legal frameworks, such as the Water Convention. There's no need to invent something new in this regard. They are already there. As you mentioned, it is a growing instrument. So as a testament to its success, it was opened for accession by all UN member states. Currently, we're standing at 55 parties, but it's not only the parties. We have active involvement by over 100, 130 countries in our activities. So it's a great platform and a very useful framework. Second, we need the policy guidance tools, such as the model provisions. There's quite a lot of tools that are already there, but of course we need something new, especially on transboundary. As I mentioned, on conjunctive water management, we will be working on this. And thirdly, we need awareness raising, active awareness raising on the importance of groundwater and bringing data to policymakers, echoing what you said, Alice. And this naturally brings me to the invitation. So we don't have to wait for the next UN Water Conference, but I would like to invite you all to participate in one way or another to the next meeting of the parties of the Water Convention, which is coming up already next month in October, 23rd to 25th in Ljubljana, Slovenia. It is the place to discuss transboundary water cooperation.
Super.
And yeah, I'm looking forward to continue discussions there and also in other upcoming events.
We will be there, definitely. Donald John, 2 minutes.
Thank you. So I think there's a few things. I think one thing is making sure we take the opportunities where there are some. So in Africa, making sure that we are utilizing that resource to underpin economic development and not being overcautious, as Sefu has said. And then take the example that I showed of our work in India and Pakistan, recognizing this is a shared problem. So depletion happens on both sides of that border, and we have, the sort of international policy frameworks, but there's an opportunity there for scientists, for us to work together to solve these problems together. So I think that's a really important part of working across borders. I think it's, like I said, looking at the long-term perspective, so understanding how we got to where we are, to learn lessons for the policy that we want to implement. And policy, I think, should also take account of not just how we want to manage groundwater, but how we make that management work. So how do we get the human resources, how do we go out and get the data that we need? And then it's getting that data. It's getting the fundamental hydrogeological properties to understand the groundwater resources that we have, and then putting in the monitoring programs. And looking at what's important to monitor, so it's not just groundwater levels, like Sefu has said, it's managing a range of different parameters. So I think those are my kind of take-homes from today.
Thank you. Hans-Georg, 2 minutes.
Yes. I think I immediately can, as somebody who uses data and requires data, I immediately can pick up where John left. We have a lot of white spots where we actually don't know what happens underground. And getting more data, particularly in data-scarce regions, is consuming but required to know what's going on to make planning for the future. And the second thing is that, like carbon, groundwater needs to have a price. And in a lot of regions, a lease for land comes with groundwater that you can drill as much water from the aquifer underneath, like, for example, in the Great Plains. And this leads just to an overuse what people actually had. For example, Bangkok had the problem of subsidence due to groundwater depletion, but as soon as the government put higher prices on groundwater, the level stabilized, and some of the important aspects of the groundwater depletion, the subsidence, could be at least mitigated in a near-term sense. So yes, groundwater needs a price, like we want to put a price on CO2. And I think with this I already have said everything for these 2 minutes.
Whoa, challenging. Let's see that. Well, conclusions. And we would like also to listen to the audience. And we will have a Mentimeter and a QR code. So with a slide that you can go ahead with your QR code to have your opinion on what are the main, if groundwater depletion is reversible. And then, if what is in your mind the main cause for wow, it's going. Okay. So, well, we are not very much optimist. It's growing? No. We go to the other one. Yes. And what is, in your opinion, the main obstacle preventing us from effectively addressing groundwater depletion? The QR code is there. I see there was quite money, Tata, humans, money, yeah, definitely. Educations, regulation, accountability, less pumping, sure, definitely, less pumping. Well, we will put all these together, and then we will share this information. Poor understanding of groundwater flow system, mainly regional flows. Corruption, absolutely. At decision-making level. Whoa. Well, thank you so much. We will compile of these later on, and you will be able to continue to do it. Shami, in 5 minutes, conclusions. If not, the conjunctive management session that you will chair will be late.
Well,
We
thank you
start
very
late.
much indeed for the presentations and the very interesting discussions that we've just had. And of course, the Mentimeter results are also quite interesting as to whether or not depletion can be reversed. I think in this meeting we've had two key words. One is depletion, and the other one is it possible to reverse it? And we've had some panelists who have given us some perfectly interesting, very wide-ranging answers. I won't repeat what they've said. But the global overview part of the presentation, from which I've picked up a couple of things, one which says that although there is depletion around in the world, it actually can be reversed, but key of years, there is a reversal is on decadal timescale. That's a very important observation to make. It can occur, but it takes some time. It can occur spontaneously, or it can occur in a kind of planned manner. And in the other longer presentation that we had, there are 2 or 3 other key points. The most important one of them seems to be that we need to make informed decisions. I think that's a very critical issue, and I think we need to take that back. Much of the points made by the panelists were that we actually need to make informed decisions. We also had the audience's view, and I think quite a few people said that depletion can be reversed. It's very interesting that it can be reversed. Some people might think that it may not be possibly reversed. And as to what the obstacles were, there were many. Among them, I picked up money quite a lot of the time, planning, and I just wondered whether communication of science to policymakers is one of those other things. Can we, as hydrogeologists, communicate our findings to the policymakers? So if we just look at that question, how do we take our scientific findings that were presented in a very technical and scientific manner, how can we take that forward to the people who need to make the decisions? And in that connection, let me ask a straw poll. Please put up your hand if you think you're a decision maker. How many decision makers are there in this room? I can count one. How many can you count? So there aren't many decision makers over here, all scientists. So our message needs to go to the scientists. From the scientists needs to go to the policymakers, because our science by itself is not much use. So there are 3 areas that we need to refer to. One is depletion, and when we talk about depletion, hydrogeologists can immediately connect that to some form of aquifer storage reduction. If we talk about overdraft, we as hydrogeologists can connect that to some degree of replenishment of the aquifers, so we are overdrafting above the amount that's replenished. When we talk about level decline, we understand that that has an impact on pumping lifts, or it might have an effect on the dependent ecosystems. Can we reverse these sort of things? It's possible, as we've said, but it's going to take some time. And if we take our message, these messages, the front part of the messages to the policymakers, their reactions are often going to be of this kind. Alarm bells, groundwater levels limited, groundwater is polluted, groundwater is too complex to regulate, groundwater front-end investments are too complex. And I think we have a challenge to how to overcome the misunderstandings or lack of understanding in this issue. I have to say that there is optimism. Much has been done. You were here, or many of you participated in the conversion of the thinking behind invisible to make it visible, and that's been a success story. It's been understood by a lot of people. However, I still think there's a lot to do. And I think the IH congresses of this kind are really the platform from which we can take our science, the interpretation, the analysis, the conversations that we have into policy. And I think that's lacking at the moment. And I think we need to strengthen that. And I would encourage the IAH to actually focus on that, which they do through their commissions and their networks. But perhaps they need to do a bit more. And perhaps I can conclude by saying that maybe one of the ways to go towards reversing a depletion in a faster way than we might need is to go towards conjunctive, integrated water management of all the water resources. Thank you very much, and I hope that was a small short summary.
So thank you everybody for coming. Thank you the expert, the panelists, and let's work together to have an IAH voice in the international political agenda for groundwater. Thank you so much.
Interesting that a lot of people think depletion.
Thank you. and nice to meet you.